question 2. So we've got a crane. This container is mass 22,000 kilograms, being lifted by these lifting cables attached to the top corners. The container is being raised. Its center of mass is 32 meters from the nearest vertical pillar, that's PQ, this one. The tension in the 4 lifting cables is the same, so calculate the tension when the container is lifted at a constant velocity. So constant velocity implies that forces are balanced on this container. So the tensions in the cables must, and there's 4 of them, must be equal to the weight of the container, and that is its mass multiplied by G. So T, the tension in one cable, 22,000 times 9.81 divided by 4, and I'll put that into the calculator. And I've got 53,955. Everything here is the 2 significant figures, so I'll give my answer to 2 significant figures and write 54,000 newtons. Okay. Calculate the moment of the container's weight about the point Q on the key side. So this is the point Q, stating an appropriate unit. So moments about Q. It's the force multiplied by the perpendicular distance. Well, this is a horizontal distance of 32 meters from Q, and the weight is acting vertically, so that is perpendicular. So it is the force, which is the weight of this container, 22,000 kilograms times 9.81 G, multiplied by that distance, 32 meters. And again, that is going to be a job for the calculator. And I've got a pretty large number. It's 6.9 times 10 to the 6. And it says state an appropriate unit. These are moments, so they are Newton meters, because I've multiplied a force by a distance. Describe and explain one feature of the crane that prevents it from toppling over when lifting a container. So there's a few things we could have here. I think I'm going to go for this counterweight that the crane has, which is going to help to balance the moment caused by the container. So describe and explain. The description is the counterweight. That is the description of the feature. I was about to write balances, but I'm going to say provides anti-clockwise moment. To balance that of the container. And hopefully that gets me 2 marks, 1 for the description, 1 for the explanation. So each of these cables has a cross-section given. Calculate the tensile stress, stating an appropriate unit. So stress is force over cross-sectional area. The force on each of these cables we have from our answer from 2AI, 54,000 newtons. The cross-sectional area is given to us in square meters, so that's rather convenient. No conversion of units required, and check it in the calculator. And get a very large number indeed. I wish my calculator gave me answers in standard form, but this has come out as 1.4 times 10 to the 8, and that is the appropriate unit here. Force over area, it's newtons per square meter or pascals. Either of those is going to be fine. So 1.4 times 10 to the 8 newtons per square meter. Okay, so just before the container was raised, the length of the cables was 25 meters for each one. Show that each cable extended by 17 millimeters when the container was raised from the ship. So we're given the Young modulus here, and we know the formula that Young modulus is equal to stress over strain. A rearrangement gives me that strain is equal to stress over Young modulus. And strain is also equal to extension over length, so therefore I can write that the extension is equal to the length times the stress divided by the Young modulus, and at this point I just need to plug in the numbers. So the original length, 25 meters, multiplied by the stress that I've calculated in the previous answer, divided by this Young modulus, should give me the answer that I'm looking for. So I'll put that lot into the calculator. And I get an answer of 0.0167 meters, which is indeed approximately 17 millimeters as required. Question 2 done.